let's talk turkey now. So we talked about addition and subtraction. I hope that that made some kind of sense to you, right? The key here about making sense and understanding is to convince you that even though procedure and repetition plays a large part in your learning process, that math is not just a bag of tricks. It is not a magic show where stuff happens, you don't have any input or questions or ability to make sense of it, the situation, right? It's such a common theme that I hear from my students. You know, is your answer right? I don't know. I don't know what I'm doing really. I'm just trying to repeat what I saw. And I want to break that cycle a little bit, because I think that you taking control of the situation and trying to make sense of it is a huge part of the confidence piece of math. You see, math is not just about skills, and it's not just about understanding. When you go to take a math test, there's a third piece of that, which is really critical, and it's confidence. Right? And confidence doesn't just come out of the sky, right? You don't just get gifted with confidence. And people that have traumatic math histories, bad experiences with math, come in and this is shot. There is no confidence whatsoever about their ability to understand math, to do math, to make sense of math. So that's the piece that is very hard to build. And I think my argument is that the understanding part of it is really important. You know, again, not so that you have to understand everything that happens in math, but that you know that it can be understood, especially if you're willing to put in the time and the work to make sense of it. Okay? It's a little more challenging to talk about understanding, but I think it's important. Okay, so let's talk about multiplication. 2/5 times 3. Let's just start with a fraction times a whole number. All right? So if I have 2 of something, which I do, I have 2 of this thing called a fifth, and I want to multiply it by 3, right? Then I have 6 of the same thing, right? It's like I have 2 chairs, okay? And then I got 3 groups of 2 chairs, that's 6 chairs. So this is the same thing that's happening here. What's wild is that once I move into a fraction times a fraction, like what is a half times 3/4? Okay? Now first of all, we can draw this picture and try to make sense of it. I'm going to write it like I said a half of 3/4. Now first of all, if that was a half of like 6/4 or 10/4 or 8/4, I could easily find half of that because I could just take the numerator and divide by 2. But because this is 3/4, I got a problem. Like I can't take 3 and divide it nicely by 2. Here's my picture of 3/4. There's a couple ways to do that. I'm just going to do it by dividing everything in half. Take a half of that, take a half of that, and take a half of that. Now, I don't want all of that. I want 1 out of 2 of each of them, right? So I'm going to color that red. This part, and this part. So I've got 3 of something, right? And the question is, what do I have 3 of? And the answer is kind of surprising. I have 3 of a new thing called an 1/8. Okay? I have 3/8. Why is this an 1/8? Because if I finish, right, cutting fourths into halves makes them into 1/8. And we get this thing here where really it's just 2 times 4 made 8, right? That's the effect of multiplying in the denominator, is changing the kind of the piece that I'm talking about. And all of this is good news, because guess what? To multiply fractions, all I have to do is multiply across. It is the most intuitive fraction operation that there is. 2 times 4 is 8, 5 times 7 is 35. And we don't have to think about all of that. I got 7, so I'm going to divide them into 5 pieces, and I had 2, and now I'm going to, I got 4 of those, so 4 2s is 8. It's really very simple. We just multiply across. Okay? But that explanation back there was a way to try to get you to start thinking about the top part and the bottom part of what actually happens. Okay? Normally this gets taught first because in order to add and subtract, we utilize multiplying fractions, right? If I want to add 2/3 and 4/5, I scale this up by 5, 5. So this part is actually fraction multiplication. I'm taking 5/5 and multiplying it by 2/3 to give me 10/15. And I'm taking 4/5, multiplying it by 3/3, which is a fraction, and that gives me 12/15. So I end up with 22/15. Okay? But I think that you can make sense of the part about scaling up without really thinking about the multiplication operation. And now that it kind of fits into place, right? We just multiply across, and that's what multiplication with fractions is. So I can write that as one multiplication sign, right? 5/5 times 2/3 is just 5 times 2 and 5 times 3. Now, the awesome thing is that division is actually exactly the same. We just divide across. So for instance, if I have 8/9 and I want to divide it by 2, well, I've got 8 of something divided into 2 groups is going to give me 4/9, right? If I write that out as fractions, remember any whole number can be written as a fraction by just putting it over 1. So if I divide across, look at what happens. 8 divided by 2 is 4. 9 divided by 1 is 9. That answer, which makes sense because I had 8 of something, right? If I have 8 dots and I cut it into 2 parts, then what I end up with is 4 different groups, right? That's where my 4 came from. Now, the problem, you thought there was a problem coming, there is. The problem is that sometimes when we divide fractions, 3/7 divided by 2/4, 3 divided by 2 is not a nice number. And 7 divided by 4, not a nice number. So what are we going to do? Somebody smarter than both of us came up with this amazing insight about division. All right, I'm going to tell you, and I'm going to try to explain it to you and break it down, and then we'll just get some practice doing it, right? Because there's 2 sides. There's the skill, the procedure, repetition, and there's, what's going on here. So here's how it gets resolved. The person realized that dividing by 2 is the same as taking the denominator and multiplying it by 2. Because if you think about it, here's thirds, right? If I divide each of my thirds into 2, what am I talking about? I'm talking about sixths. We already looked at that. A third divided by 2 is actually 1/6. Because dividing by 2 is the same as multiplying by half, taking the denominator and multiplying it by 2. That's a key insight. Dividing by 2 and multiplying by a half are the same thing. And here's the real trippy part. If I take something and divide it by a half, it ends up being the same as multiplying by 2. I'll show you. Let's take something that actually divides by half, like 3. 3 divided into halves, okay? Now, I'm going to draw 3 circles, and I'm going to cut them into halves. There we go. I divided it into halves. How many halves do I have? 1, 2, 3, 4, 5, 6. The answer to this is 6. And yes, you know as well as I that 3 times 2 is 6. Okay? But forget about this part. Think about it. If I divide something into halves, I'm doubling what I have, right? I mean, the things that I'm talking about now aren't as big as they used to be, because now I have 6 halves, right? Instead of having 3 wholes. But that's the effect of dividing by half, is that I double what I have, right? Boom. Every 1 becomes 2. And that's the insight about what happens when you divide by the denominator is it goes to the top and scales up the numerator. Bottom line, that this is true. That dividing by 2/4 is the same as multiplying by 4/2. And that's the tool that we use to make division easy, because there are a lot of times when we divide fractions where the top doesn't divide evenly, the bottom doesn't divide evenly, or neither of them divides evenly. But if we rewrite it as multiplication, then we can always multiply. 3 times 4 is 12, 7 times 2 is 14, bam, there's our answer. So that is the trick that is used to accomplish division of fractions, okay? So let's summarize where we are here. Multiplication and division straight across. That's option number 1. It's very intuitive. For division, we often rewrite as multiplication. Okay? All right, so again, get some practice, then we'll get some mixed practice with addition, subtraction, multiplication, division. And the thing for you to do here is really like think about, you know, what are the operations, what are the connections between addition, subtraction, multiplication, division? What do I do when I see an operation? How do I approach that? Okay, and I really want you to go back to this if it's helpful. Think about why you're doing what you're doing. But on the other side, it's just going to come down to repetition. Like the more times you add fractions together, the more comfortable you'll be with it. Don't use your calculator to add fractions. I mean, if you want to do 7 plus -10 or 7 minus 10 on a calculator, that's fine. But there are certain calculators out there that will add fractions for you. And the reason I say don't use that is because if you put the time in to become comfortable with this skill, it'll be there for you. And it'll be there for as long as you need it, as long as you keep that sharp. And the problem is that fractions derail a lot of students. There's fractions at every level of math that you're going to walk through. And fractions, you know, exist in the world. I'm not saying that you have to often take 2/3 of a pizza and divide it by 3/5 of a person. Like that situation doesn't happen very often. But in terms of your mathematical journey, this is an important piece of the puzzle because it pops up so much and it helps simplify if you understand how to use fractions. All right, good luck.